This is the second session devoted to electronic instruments, and we have 3 presentations that respectively explore conservation techniques related to maintaining living technology, the evolution of hardware electronic music viewed through an analysis of the design of an instrument, and an important exposition on the determinism and impacts of language in electronic music instrument design. Each presenter has 20 to 25 minutes to present, and I'll be inviting some brief questions from the audience following each presentation. You guys know the drill. I'll also be holding them to the clock to make sure that the proceedings run as scheduled. So with all that being said, I'm delighted to introduce our first panelist this morning, a gentleman I've had the privilege of working with over these past 8 years. He predates my tenure here at National Music Center. He's a studio electronics engineer for NMC, and he's been working towards the accessibility of our music technology collection at Studio Bell for almost a decade. Please welcome NMC's own Jason Tawkin.
All right, thank you so much for having me. It's finally good to be back at these conferences. I know I was slated for the last one in 2020, but the 2 years off gave me some time to work on a brand new project. So that's what I'm here to speak about with you today. Really excited. So as you can see, we have a collection of living instruments, but also music technology, and they have this symbiotic relationship in the studio. The tone capture devices become just as important as the instruments that are making the tones. So this is the light that I'm going to shed on this important artifact that actually preserves musical performance in perpetuity. So this story starts all with Triad Studios. And Triad Studios was one of the many independent studios that popped up around London, England in the 1960s. One of the most famous ones was Olympic Studios, which was famous for making all of their own equipment, and this was very sought after. At this time, there was very limited recording equipment. Basically, you would have to repurpose broadcast equipment, radio mixers, that sort of thing. But this feature set really didn't allow for the evolution of recording equipment technology and capture technology, particularly multi-track recording systems. So these different systems didn't integrate at all. So Triad Studios was very significant, and it was started by Norman and Barry Sheffield, brothers who were entrepreneurs in England. And their whole spiel was state-of-the-art. So they're standing there in front of the very first console that was at Triad Studios, and it was made by a company called Sound Techniques, and it was the very first 8-track recording studio in London, which was a big deal. So this capability actually basically made it very desirable for lots of different clients, and they had tremendous success right off the bat. So everyone from the Beatles to David Bowie to all of these bands that were A-list stars were drawn to the lure of having 8 different tracks for their recording sessions. Now, the other person that's very significant, one of the staff engineers at Triad Studios, is pictured there behind the console, and his name is Malcolm Tulf. And he was basically one of the engineers that worked up towards chief engineer and really had the backing of both the brothers and the owners. So the studio was very successful, and basically they wanted to maintain that success, so that meant staying on the leading edge of technology. And so right around the corner, right after 8-track recording, we see the advent of 16-track and then 24-track. The problem is your equipment doesn't necessarily easily integrate with that. So they started to begin to figure out what are we going to do to replace the Studio Techniques console with a more capable, robust system that's more expandable and upgradable into the future. So Malcolm actually met with different manufacturers and actually asked them, hey, can you build a console that's expandable in the future? And one of the problems at Triad Studios was they only had about 1.5 meters in the control room. It was a very tight space. And at this time, electronics took a lot of actual physical space to get the ergonomics and the different functionality that was required of the studio in those days. So through some convincing and through one of their techs, Barry Porter, who was the maintenance engineer, they had some success building a tape transfer console in-house. And they decided, why not build the console for the new 24-track setup for the main studio in-house. So here we see Malcolm Tulf building the original prototype Trident A range. And basically what they did was they had a room upstairs in the studio, and they decided to quarantine it for this project and basically experiment and build this one-of-a-kind prototype console. What was really unique about the whole experience of this particular approach to procuring equipment was it was more of a DIY project than it was having specifications and then going to a manufacturer and trying to find a manufacturer that would meet those specifications. So this allowed for a lot of creative input into the actual design of the electronics, the ergonomics of the console, as well as the look and the feel. Now, I say DIY project because not all of the circuits within the A range are completely unique. So above in the right-hand corner here, we've got a circuit from a Studer tape machine for a mic pre, which is a 3-transistor design, and below is the Trident A range mic pre design. And there's a lot of commonalities, but that's pretty on par for the era. People borrowed from different designs. The other significant thing about designing the actual circuits in the board was they had a wonderful plethora of in-house engineers. So people like Roy Thomas Baker, Ken Scott, Malcolm Tulf, all now famous record producers, were on staff and actually contributed to the R&D of building the tone controls and the amplifiers of the new mixing desk. And you gotta love that color. It was inspired by an eggplant. Apparently, Roy Thomas Baker picked it aubergine or eggplant in North America. So basically, because they had such an amazing team and they were so entrepreneurial, the Sheffield brothers really wanted to divide the different businesses up. So they had Trident Studios proper, which was the studio business. They had Neptune Productions, which was an attempt at a production company and management company, one of their first biggest clients being Queen. And last but not least, they promoted Malcolm to basically the managing director of Trident Audio Developments, and they abbreviated that as Triad to the marketplace in the early 70s. So this is the prototype of the original A-range console, and as it appeared back in the day in Trident Studios. So you can see it was really state-of-the-art. To the left, we have, it's a little bit earlier than the right, and you can see there's a lot more equipment that's been added. So it was an ongoing process, and anyone that's been involved with any studio knows that it's never done, and it's a bottomless money pit. So that brings us to our console. And so this is really exciting. Basically, Triad went into business based on the success of that very first prototype console, and orders began pouring in from different studios because they had the same problem. They couldn't get 24-track equipment. So this is a really interesting studio in Copenhagen, Denmark, called Rosenberg Studio. And it was started by Ivar Rosenberg. And it was in Copenhagen, Denmark, and attracted a lot of different clients. T-Rex did the Slider there, a number of other albums. Gasoline was a Danish band that recorded there. And this is the actual Trident A range that we have here in the collection as it was installed in its very first control room in 1975, which is pretty neat. So after the console is at basically Rosenberg Studio for a while, the studio kind of dies out towards the early 80s, and it's transferred to a studio called Easy Sound. And it's also in Copenhagen, and by the mid-1990s, the console becomes kind of so archaic from its 70s kind of approach to signal flow and design that they actually hired a firm called Keops, a local electronics engineering firm, to upgrade and modernize the console. So a lot of different new features were added. This is a block diagram of how those features work. But basically, they were trying to take this console that sounded really good and make it a little bit more ergonomic. So over the lifespan of this artifact, it's had lots of different technicians and lots of different approaches and a lot of different eras of technology that it's actually been responding to. So sadly, I'm not the first, and I won't be the last to work on this console. And after its stint in Copenhagen and in Europe, it finds its way to North America via Bomb Factory Studios. So Bomb Factory Studios was a pretty amazing studio in the late 1990s through the early 2000s that really pushed a lot of this new concept of a hybrid approach to using historic instruments, using historic recording equipment, maintaining it, making it available, and having their clients and their artists really kind of pull inspiration from all these relics of technology of the past. So the Bomb Factory had a good run for studios. We try our best to keep in business as long as we can. But eventually, digital recording and things changed, and the marketplace changed, and an analog recording studio didn't work as well. So when we actually heard about the Bomb Factory closing, our former electronics technician, John Limesider, who you saw in the video yesterday, while he was still in LA, did a lot of service calls to this particular studio and worked on the A range there quite a bit. I joke with people quite a bit about owning a British console is exactly the same as owning a British car. You can't get the parts and you have to service it all the time, and you might as well be a mechanic. So we opened Studio Bell in 2016, and the A range was designed as the centerpiece to our main studio, Control Room A. So it was a quite vigorous install process because we actually installed 3 historic recording consoles all at the same time. 2 of which had been restored before we moved on site, and then this one was restored in place. So when we installed it, a lot of the capacitors began leaking from a previous recap, and were leaking basically corrosive material onto the traces of the circuit board. So John actually recapped most of the board in 2016. As we began using the console and it commissioned it, we all were very happy with the sound and the capabilities of it, but soon it became unreliable. And all that unreliability had to do with the switches in the input section. So what you see here is a circuit, or it's a layout diagram of all the components that exist within the input module. So the input module is what actually amplifies and gives you tone control of your microphone signal. And then that signal is routed to a tape machine. So these tone controls, based on the different selections, are selected by switches, and you can see the switch banks there. And these are the parts that went faulty. So we needed to find new switches. As you can see, the original switches suffered from a lot of corrosion. In the center image there, you can see that the posts that actually make electrical contact, they're kind of going like an aqua green. That's a sign of corrosion. The other thing about these switch banks is they were completely exposed. So from the back, you can oxygen, debris, whatnot, can get right into the switch bank, and basically it can cause problems on the switch contacts. So we began looking for new replacement parts at the end of 2020, and it was quite the endeavor just to find new parts for something that was built in 1975. While the switch functionality was pretty common, the actual form factor had changed quite a bit. So that meant we had to do a lot of reverse engineering to get a new part to fit. So we were eventually able to find a new part, it was a quality part, meaning it was gold contacts, they're sealed, it's rated for a very long lifespan. So eventually every switch will fail, even your light switch at home. If you flick it enough, it will stop working. So every switch, every component has a lifespan, and we wanted to maximize this so that we get another 20 years out of the console before this has to be done again. So we began the process of procuring the switches, which was a nightmare during a global pandemic. I believe I ordered the switches in July or January, and they showed up in August. So we ordered 750 switches. I needed 395 to do the desk. So now we have enough switches in our collection to do the desk a second time into the future. So hopefully we're good for the next 80 years. And there was a lot of unexpected twisted turns, one of which, when I was procuring the parts, is I had to promise that I wouldn't make weapons of mass destruction with the switches that I was procuring. And it's safe to say that Canada Customs must have known it was at the bomb factory. So once we had the switches, we needed a way, because they're actually, by the end user, they're actually physically engaged by the end user. It has to feel and look like the original design. So the switches needed to be basically mounted within the input module. So we started with these very kind of crude drawings and concepts, and I wanted to use the original brackets, as you can see here, And basically, there was two mechanical parts, a bracket that held it to the face plate and a bracket that held the switch bank to that bracket. So in designing this, it quickly became apparent that there would be multiple parts that needed to be customized. So basically, I went back to the drawing board and came up with a second design. So this second design actually deleted one part and made it more universal. So on the top of the module, there's two switch banks, 3 and 3, and then on the bottom of the module, there's a switch bank of 3 and 2. And I was able to design a bracket that actually accommodates both switch banks, which made it much easier to manufacture the part. Instead of having to procure 3 different custom-made brackets, we are now just down to one part to get the job done. So I worked with a local metal manufacturer here in Red Deer, and with the drawings that we made, eventually got through a prototype and actually built the metal bracket. And it was quite the endeavor, but eventually we got a part to work. So the next thing that we needed to do was design a PCB. So I actually, just to get the sizing right, we prototyped with some breadboard just to feel it out. And then using the original schematics for the high and low pass filters, developed a schematic and a PCB that would limit all the different, basically normaling between the different switches. So originally they would have wired with pieces of wire from one switch to the next, and it would have taken a long time. So in actually designing a PCB, we cut down a lot of the time it takes to wire up the banks into the modules, but we also can use the PCB to actually hold the different switches to the bracket. So it's dual purpose. I think my remote died. No, we're good. Okay, so through many iterations, I think it was like 3 or 4 PCBs, we finally got to a final PCB. And so you can see the old switch bank there, and then the new PCBs, and then the new PCBs that are actually ready to be installed into the brackets to complete an entire switch bank module. So those are the switch bank modules with the brackets, and now they're ready to be installed into the console. So installation is no easy feat. It requires a complete disassembly of the whole front panel assembly. And a lot of these wires were very brittle, and a lot of the different component switch points had actual physical components going to them. So rather than a piece of wire, it's usually like a capacitor or resistor. And some of these capacitors, some of these resistors, and some of the wiring and insulation had become brittle and pretty soft. So it's a very slow, painful process, but eventually we got to a point where the new switch banks were installed. So the switch banks, previous to being installed, when you would plug in a microphone to the input strip and you would press one of the switches, the sound from the microphone would go away completely. And we affectionately dubbed this the no-pass filter. And it was immensely frustrating for recording engineers that were visiting and people, especially in a legacy studio where you have vintage microphones and vintage instruments. It's very hard to pinpoint where the signal is breaking down. So this new switch banks basically add reliability to the whole recording setup. There was actually oftentimes where a performance would be ruined because one of the switch contacts would come undone during the performance, even though you didn't touch the console at all. So you can imagine how invigorating that was and how happy we were when we got new switches. So here's a before and after. As you can see, the original bracket that was in the module has been now removed, and that was very deliberate. So this entire switch project was done in a way that we can reverse it at any time in the future. So there's no real destructive activity occurring here. We're simply unsoldering wires and removing them and putting from one switch bank to the next. So the nice thing about that is should someone want to redesign it in the future, they totally can. And should someone want to put it back to the way it was, they totally can. But more importantly, this new solution meant that we can actually service the console now. So we are walking this tight rope of having this collection preserved, but also using it. And so when someone books a recording studio, they expect the console to work perfectly. But we also want to kind of retain all of that history that we spoke about earlier. So it was really important that we were kind of conservative in our restoration, and it was important that there was kind of no destruction happening. So the console is now slowly being rebuilt. One of the challenges is we can't just pull this out of commission. So we're actually doing 2 channels at a time. And we've got 3 channels done so far. And so by probably the end of the summer, the complete desk will have all new switches and no performances will be lost. So that's my presentation. I guess we'll do some Q&A.
Yeah.
Thank you so
Jason
much.
Tawkin, everybody. Give it up. So we've got some mic wranglers on the sides here. We just asked for questions. It'd be nice to get it amplified so the folks at home can hear. We got a hand up over here.
Hey, so let me preface this by saying I am not an electrical engineer, so if anything I ask sounds idiotic, excuse it. So I have 2 quick questions. One about switch heads and one about capacitors. So switch heads,
Yeah.
when you were replacing the switches, were you trying to find a way to use the original switch heads on the new switches, or did you have to manufacture new ones that resembled the old ones?
Yeah, so luckily those particular form factors are very common, and we were able to find new ones. The old ones had become very brittle, and a part of that was the preventative maintenance that was happening when the switches failed. So there's contact cleaner. If you've ever turned up your radio and it's like, there's a spray you can get in an electronics shop that's contact cleaner, but it's pretty nasty stuff, and it's especially hard on plastics. So though a lot of the original input switches had, and as we were using them in the studio, you would press the switch and the switch would crumble beneath your finger. So it was important to just replace all of those. And now we've got all the original ones in a bag, and now we can replace as needed, because they're basically like kind of more disposable at this point.
All right. And then about capacitors. When you were replacing the leaky capacitors, were you essentially using new old stock, or were you using a more modern solution that would be less likely to leak in the future?
So modern solution, basically a lot of the old capacitors, like it's hit and miss. A lot of people will say like you have to recap everything. It's not really the case. You have to recap sometimes, and it depends on the chemical composition of the cap, which was changing a lot during the 70s and the 80s. Now they're at a much basically more stable state and more accurate and better tolerances. So basically, all of the capacitors that we replaced when we moved the console in were new components. The tricky thing about new components is the values that are available diminish year after year. So it's very difficult to find the correct values for whatever project that you're doing as time goes on.
And then I don't want to steal the mic much longer, but you were talking about some of the traces, like when these caps leak, they start to eat into the board. Was anything destroyed to the point where you had to replace a board, or did you get to it soon enough that you could clean up the trace and it was functional?
Yes. So none of the traces were destroyed, meaning that they all still had continuity, so electrons could still flow through them. But we were concerned about the future. So if you leave that corrosive material, it's only a matter of time before you don't have continuity, and then things are not working anymore. And that's a real scary thing when your PCB doesn't work.
Okay, we've got about a minute left, so one quick question. Is there any quick questions for Jason from the audience? One over there, okay.
So in replacing parts that fail to maintain the functionality of the table, at what point do you feel that it's no longer the table that it was? Or, and does that matter?
Yeah, no, it's important. So I think it depends on the component. So for example, some components will not affect the sound at all, and some will. So in the example of a switch, it's a pretty primitive concept. It's no, like, these switches are no different than your light switch. They just have 4 light switches that all happen at once. So there's no real difference between the end user, but one of the things that scares me about the future is, for example, the transistors. So all of the transistors in this console, most of them are made by RCA and no longer available. Now, I can substitute them with modern equivalents, but that will change the sound. So it's on a case-by-case basis. We've done our best to collect as many legacy parts as possible, but as time goes on, they're getting scarcer and scarcer. So at a certain point in time, there may be a channel that needs a repair where the sound maybe slightly will change, but in that case, it's better to have that channel working than not working ever again.
Okay, we're out of time. Thank you, Jason Tawkin. Give it up for Jason Tawkin, please.